Okay, so come back again, right. So that's why this your these two equations you can write in the matrix form, right. So it is 1 upon r1 plus 1 upon r2, and this is minus 1 upon r2, and here it is minus 1 upon r2, 1 upon r2 plus 1 upon r3, v1 v2 is equal to 4 6. So these two equations can be solved, right. But here it is only two your what you call only two unknowns. So easily you can solve, right. No, even no matrix operation is required, just you can substitute one after another and you can easily solve it. But if if it is your what you call, if it is more than 2, 3, 4 or 5, say something it comes, then you have to follow certain techniques. So just Cramer's rule we will discuss here, and one small technique I will show you which is valid only for 3 into 3 matrix, right. So this is simultaneous equations and Cramer's rule. So little bit for circuit theory analysis, as I thought little bit idea is required. So that's why I have taken this thing, the small mathematics, right. So consider a set of simultaneous equations having this form. The equation is a11 x1, right. I am just making it like this. It is a11 x1, a12 x2 up to a1 xn is equal to say b1. This equation one, the one equation. Similarly, a21 x1, a22 x2, a2n xn, this is say b2. Similarly, last one an1 xn, an2 x2, sorry, an1 x1, an2 x2 up to an xn, it is say bn, right. So you have n number of simultaneous equations and b, right. So this equation, if you put this equation in the matrix form, let me clean it. If you put this equation in the matrix form, then we can make it like this, that a11, this is your A matrix, this is your A matrix, it is a11, then a12, a1n, these all these things little bit you have studied in your higher secondary, right, in matrix chapter. And this is A matrix, this is your x1, x2, xn, right. So A matrix is n into n matrix, right, and this is x is actually n into 1 vector, and right hand side this b1, b2, bn, it is actually b or what you call n into 1 vector, right. So this is actually given an equation 10. So this equation it can be written as Ax is equal to b, or x is equal to, directly solve x is equal to A inverse b, of course if A inverse exists, but anyway sometimes we do not follow A inverse, we follow different method to solve such linear equations, right, for computational efficiency. Now this is actually your Ax is equal to b. Now A is equal to your A matrix, this a11, a12, a1n, a21, a22, a2n, then nth term an1, nth row an1, an into ann, right. Similarly, x is equal to your x1, x2 up to xn, and b is equal to b1, b2, bn. So A is a square matrix, n into n matrix, where x and b are column vector, that is n into 1 matrices, right. So it is actually column n1 into, we can write n1 n into 1 matrix, right, matrices. So there are several methods for solving equation your this above equation Ax is equal to b, that is your back substitution, Gaussian elimination, matrix inversions, Cramer's rule, and numerical analysis. There may be many methods for solving such this thing, but you have to apply which will be computationally efficient. But anyway, we will not do any, we will not write any computer code or anything. So only we have to solve those things which can be solvable in the classroom as a classroom exercise. Accordingly, we will see, right. We have to see that classroom how we can quickly we can solve this one. So Cramer's rule, actually Cramer's rule can be used to solve the simultaneous equations. According to Cramer's rule, the solution of equation 3.10, that is your Ax is equal to b, right, that is your if the equation is your Ax is equal to b, right, when you are solving this equation, so it can be easily solved. X1 is equal to delta 1 by delta, we will see what is delta 1 or delta, x2 is equal to delta 2 by delta, and xn up to that delta n by delta. So we have to find out delta 1, delta 2 up to delta n, and then delta, 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 right. So delta is the deltas are the determinants, but we have to know some procedure that how to solve it quickly, right. So in this case what we will do, that delta is the determinant, and then the delta 1, delta 2, all delta n also determinant, but how to obtain this, where the deltas are the determinant given by this delta is equal to your this determinant you find out, this is basically it is the a11, a12, a1n, A21, A22, A2n, and AN1, AN2, ANN. This is the determinant delta. Now, for delta 1, delta 2, delta 3, what you will do, right? Look, just you look that what you can do is for delta 1, for you have to find out x1. x1 is equal to say delta 1 upon delta, x2 is equal to say delta 2 by delta, and xn is equal to your delta n by delta, right. So, how you will do it, that this is the first, if you take the first column, this first column only you replace by B1, B2 and Bn, rest will remain same. So, that is whatever determinant will come, that will be delta, that is why B1, B2, Bn, the rest all the elements from here to here, all the elements, this all the elements it is same. Just for delta 1 you will replace that first column of this of A11, A21 up to it replace by B1, B2, Bn, just replace it and calculate delta 1. Similarly, just let me clean it, that will get delta 1. So, similarly your delta 2, in the case of delta 2, just replace your what you call the second column by B1, B2, I mean the second column of this matrix, this is the second column, right, this is the second column, this is the second, this is that your second column, this one you replace by B1, B2, rest for a rest all the A's element remain same, only replace that, then you will get the delta 2. Similarly, for the delta n, the last one you replace by B1, B2 and Bn, rest of the all A elements will remain same, you will get delta n. This way delta 1, delta 2, delta 3 all can be determinants can be computed, right. Then direct solution, then you will get once delta 1, delta 2 up to delta n known, then x1 is equal to delta 1 by delta, x2 is equal to your delta 2 by delta, x3 is equal to delta 3 by delta up to xn is equal to delta n by delta. So, this way you can easily solve it, just replace one column, just shifting, right. So, let me clear it, right. So, now question is that how to make it. Now, if delta is the determinant of matrix and delta k is the determinant of matrix formed by replacing the kth column of matrix A by B, this I told you, all these things I told you, right. So, only thing is that it is evident that Cramer's rule applies only when your what you call that your delta not is equal to 0, because it will be division by 0. So, not possible. So, when delta is equal to 0, the set of equations has no unique solution, because the equations are linearly dependent, right. So, in that case you will find the equation has no unique solution, because the equations are linearly dependent. So, the value of the determinant delta can be obtained by expanding along the first row. This I have underlined, along the expanding along the first row. So, how we will do it? So, if it is given like a little bit bigger, we have written that A11, A12, A13 up to A1n, then A21, A22, A23 up to A2n, right. Similarly, A31, A32, A33 up to A3n, and then AN1, AN2, AN3 up to ANn. Now, if you write like this, that then you have to mind this thing. Say let us is first one we are writing A11, M11, right. But basically can be obtained expanding along the first row, that means along the first row we are trying to expand. Column wise also can be given, both we will see, right. So, in that case A11 M11 minus A12 M12 plus A13 M13 plus dot 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 plus minus 1 to the power 1 plus n, then A1n M1n, right. So, where this is determinant, that we will see later. So, look at that, this one this is A1, our objective is you have to find out M11, M12, M13, and last one is that is your M1n. Particularly look at the last term, minus 1 to the power 1 plus n into A1n into M1n. So, if you know the M matrix M, then determinant this M1, the determinant that M11, M12, M13 up to N1n, then easily can be solved, right. So, how to get it? So, let me clear it. So, the minor, this is actually the where the minor Mij is an n minus n into n minus 1 determinant of the matrix formed by striking out the ith row and the jth column, right. So, later we will see that you just strike it off ith row and jth column. For example, because it will be your just 1 minute, it will be your it will be it will be your n minus 1 into n minus 1 matrix, right. There is a minor. Now suppose it is Mij, right. So it is ith row, say I is equal to 2 and j is equal to 3, that means second row and third column, right. So if you replace that, rest of, suppose second row, ith row, suppose this row, this is gone, say this is gone, say this is not there, ith row and jth column, so that is j is equal to 3 third column. So just these two will go, rest of the elements will be there, right. So accordingly it will be n minus 1 into n minus 1 matrix. So rest of the element, this one, this one, this one, all will be there, right, and this will not be there, completely gone, but this one, this side will be there, this will not be there. So this row column you have to just eliminate, and rest the matrix order minor will be your n minus 1 into n minus 1, because one row and one column is completely eliminated, right. So let me clean it, right. So similarly, the value of delta may also be obtained by expanding along the first column. If you see that rather than rows, if you expand this along this first column, right, that also you will get that your what you call the value of delta. So just if you let me clean it. So if you make it, if you what you call, if you make this one, then it will be delta is equal to A11 M11 minus A21 M21, because we are moving towards the column, right. So expanding towards the column. So A11 M11, then A2 minus A21 M21 plus minus plus, then plus A31 M31 plus up to that minus 1 to the power n plus 1 An1 Mn1. Here also when you are expanding this plus minus, right, and then it is coming minus 1 to the power 1 plus n 1 n. This is expanding your what you call along the first row, but the same thing will get along the first column. So second equation is your along the your what you call the first column, right. So this is A11 M11 minus A21, this thing. Suppose for a 2 into 2 matrix, right, for a 2 into 2 matrix, determinant is simple, A11 A22 minus A12 A21, this you know. For a 3 into 3 matrix, it is suppose A11 A12 A13. Look, in the classroom purpose, I think maximum we will solve up to 3 into 3. We will not think about 4 into 4, because easily it can be solved, I know, but it will be more time consuming, but we will solve only up to your what you call that 3 into 3 matrix, right. That way we will formulate the problem in the assignment, right. So this one, this is a simple your delta is equal to A11 A12 A13, then A21 A22 A23, then A31 A32 A33. Now if you expand this, you are in the direction of the your column A11 A21 A31. Now look, it is that if you see the last formula, this last one, that nth term is your what you call, it is your minus, if you see the nth term, it is just hold on, if you see the nth term, then it is your minus 1 to the power n plus 1, then A n1, then M n1, right. This is your, now what you do is you put n is equal to 1, n is equal to 2 and n is equal to 3. If you put n is equal to 1, then it will be minus this one first term, right. So it is minus 1 square, then A11, then M11, right. Similarly, if you put n is equal to 2, it will be minus 1 cube. So minus term will come, then minus A21 M21. If you put n is equal to 3, then it will be minus 1 to the power 4. So it will be plus, then A31 M31, right. So so let me clean it, right. So that's why this, when we expand this, it is coming like this, right. Suppose A11 first one, then minus 1 to the power n plus 1, that is this thing your what you call, then your this if you go to this formula M1 Mn1, when just you see this one, for example, everything will remain same, that is your say Mn1, right. then you are writing a n 1, then minus 1 to the power say n plus 1. Now, if you look into that n is equal to 1 means it is a 1 1 is there, n is equal to 1 means this is minus 1 square. So, it will be plus, then this term a 1 1 coming, then m 1 1. So, ith row and m 1 1 means here I is equal to 1 and j is equal to 1. The ith row and jth column you eliminate, right. So, ith row means first row and first row column you eliminate. So, this is the first row and this is the first column. If you eliminate, remaining will be A22, A23, A32, A33. So, A22, A23, A32, A33. So, this is the first one. So, it is understandable to you, right, no problem. The second one, let me clean it, I will come. Second one, that, right, second one again, it is again your say it is again your, just hold on, let me clean it. Just hold on. So, in second one, it is again the same term we are writing minus n plus 1, then a n 1, then m n 1, right. Now, in this case second term n is equal to 2, that means it is minus 1 to the power 3, then a 2 1, then m 2 1, right. So, minus 1 to the power 3 means it is minus, right. So, this is actually minus 1 cube. So, it will become minus a 2 1 is there, and what is m 2 1? So, here m I j, I is equal to 2 and j is equal to 1, right. That means your second row and the first column. So, second row means this one will go, right, and I is equal to 2 means ith row. So, second row and j is equal to 1 first column, and this one will your what you call it will go. So, what will be there? A1 to A13, A1 to A13 and A3 to A33, A3 to A33, right. So, this way minors you can easily obtain. So, I hope these things is understandable to you, right. So, let me your what you call clean it, right. Similarly, last one also, last one shall I tell you, or I think last one also you will be able to understand, because n is equal to 3. So, it will be A31 minus 1 4, right. So, I is equal to 3, then with third row and your first column, right. So, third row and first column will be eliminated. This is the third row. So, A1 to A13 and A1 to A13 and A2 to A23 will be remaining, right. So, this way you can find out. So, this is a 3 into 3 matrix. So, will not go beyond 3 into 3 because it will take more time, but this is the methodology that how to find out. This I have expanded in the your what to call in that your column side, right, in the index of the column side, not in the rows, but same thing, row wise also you can do it, you will get the same result. So, if you multiply this all these things, if you simplify, you know how to simplify it. So, you will get this is my delta, right. So, another thing is that this method just true for 3 into 3 matrix. Remember, this is one technique is there, that a simple method for obtaining the determinant of a 3 into 3 matrix is by repeating the first two rows and multiplying the terms diagonally as follows, right. It is a very simple thing, but remember it is only true for 3 into 3 matrix. It is only true for 3 into 3 matrix, not 2 into 2, not 4 into 4, but this will be very useful for you, and you will see how quickly you can obtain it, right. So, let me clean it, right. What you will do it, just very easy to understand. What you do it, that this is A11, just hold on, this is A11, A12, A13, A21, A22, A23, A31, A32, A3. This cross I have made it, just how to do it this, right. Then what you will do, this first two rows you repeat further, right. First two rows you repeat, that is A11, A12, that is A11, this is A11, A12, A13, you repeat, and A21, A22, A23, A21, A22, you repeat, you make it like this. So, first thing is your 3 into 3 matrix, this is your 3 into 3 matrix, and then what you do, you repeat the first two rows, A11, this is A11, this is A11, A12, A13, A21, A22, A23, you repeat. Then you see how quickly you will get it. Let me clean it. Then what you do, then your what you do, that you go for your multiplication and algebraic sum. Algebraic sum means this one a11, a22, a33, this is plus sign. So a11, a22, a33, this one whatever it comes, this a11, a22, a33 may be negative, positive, it does not matter, but whatever it is you have to take plus sign. Then this one, that all these things I have taken, then plus your a21, then a32, then a13, right, this is a13, then plus this one, this will be your plus, then a31, then your a12, then your a23, this is your what you call, these are all plus sign I have made, this is plus, this is plus, this is plus, this side will be plus, and this side you take minus, right. So minus means that your these elements may be plus minus, does not matter, but sign should be minus. Then minus you take the a13, this is a13, a22, a31. So it is a13, a22, a31, right. Then minus, then this one your a23, a32, then a11, right. And then this is a23, a32, and this is a11, and then minus this another one, that your a33, then your what you call 1112, a12, then your a21. So all these things plus plus plus, all these things minus minus minus, and whatever you will get, that will be your determinant, right. So just copy the first two rows, and this side you take a11 plus, it is plus, this is plus, and this side you take minus, and just simplify, you will get the determinant. This is true only for 3 into 3 matrix. Do not try for other thing, it will never be, but for 3 into 3 matrix it is easy to compute, rather than computing your minor another thing, straightforward you will get it. This is a simple procedure, right. So let me clean it, right. That is why I make it like this. And finally if you, the way I told, whatever I wrote, same thing is written here, right. So this is your delta, same thing is written here. Next we will take the example, we will solve, it is a fundamentals of electrical engineering course. So we have to solve several numericals, varieties type of numericals, such that your your ideas or thoughts will be more or less, our thoughts will be clear, all right. So little bit practice is necessary for such kind of thing. So we will take different type of problems, and just let me tell you one thing, that this whatever I am making it, it is a scanned copy, that notes which I prepare for something, right. And if you have any, if you find any error or anywhere any calculation error or anything, please let me know, then I can rectify myself, because so many problems are there. There is a possibility that there may be an error in calculation or other thing. I do hope it is correct, but maybe somewhere something might have gone wrong also, I do not know, but I want to get feedback from you, right. So if anything you you want, if anything you find that wrong calculation or anything, then I will rectify it. But varieties of problem we will try to solve. I have collected problems from several places and try to put it here, such that you will have also our thoughts and other things, ideas and concepts we will try to clear, right. So first, take a simple example, right. So determine your what you call the node voltage in a circuit in figure 3.3a, because chapter 3, that is why marking chapter 3. Sometimes in the later stage I do not, but let us see that you have to find out the node voltages, that is in the circuit. So just this one, this is your node 1, this is your node 2, right, and this is your reference node or datum node, and this voltage V0 is equal to 0, right. So this is your datum node. It will in the new assignments or exam, whatever you get, this thing will not be marked, but you know that it is V0 is equal to 0. So this is my node 1, this is my node 2, that means this voltage is V1, this voltage V2 with respect to this reference node. This is my reference node, and we have to find out right. Node volt we have to obtain V1 is equal to how much and V2 is equal to how much. V1 is equal to how much, V2 is equal to how much, right. And two current sources are there 2.55. So, details I have made it in the next diagram, but before that I just told you that this is the thing. So, even if it is V1, V2 not marked in the circuit, if you are asked that what are the node voltages, right, then you have to assume this is V1 and this is V2, right. So, let me clean it. So, this is the detailed circuit. So, this is your reference node, this is your reference node, right. This is marked at O, and I told you that V0 is equal to 0. This is your voltage V1, this is voltage V2. Now, at node 1, this is your node 1 and this is your node 2. So, here you have to apply KCL, and here at node 2 you have to apply KCL. So, if you do so, look, this 2.5, this is a current source 2.5 ampere independent current source, this is also independent current source, this current is entering, right, 2.5 ampere is entering. So, it is your incoming current. So, is equal to, right, is equal to that I2 and I3, these are leaving this terminal node 1, this node 1 it is leaving. So, it is actually is equal to I2 plus I3, right. So, this is at node 1, but when you come to node 2, then what will happen, this I2 current actually is your what you call entering into this node. So, this current is entering into the node. So, this is I2, then this 5 ampere current also here, this is a current source, this 5 ampere current also entering into node 2. So, it will be I2 plus 5, though these two are incoming current, these are entering into the node, and is equal to your this 2 point, this is a 2.5 ampere current. So, I have marked it here, that is actually leaving the node because direction is this way, it is given, right, is equal to 2.5, right, and plus your plus the right hand side this I1, this is also your I1. So, these two equation, this is one equation I2 plus 5 is equal to 2.5 plus I1, and this side is 2.5, this is incoming current, and two other I2 plus I3. Hope I have not missed anything, because so many such problems are there, so many branches are there. So, during this lecture there is every possibility, or occasionally I also may miss something. So, if by chance it is missed during this lecture, you will also let me know that I have missed, but hopefully things are okay. Next equations, right. So, this is how we will write the equations, right. I hope this is understandable too. So, let me clean it, right. So, at node 1, so I wrote you that 2.5 is equal to I2 plus I3 is equal to that I2 and I3 equation we have to write. So, here let me mark it. So, this voltage, this your what you call that I2 and I3 we have to write, and I1 also. So, this just hold on. So, this I2 actually, if you write I2, this voltage is V1, this voltage is V2. So, it is V1 minus V2 divided by 8, this is I2, right. So, this current is flowing from 1 to 2. So, V1 minus V2. Similarly, this is your datum node O, this reference voltage is 0, right. So, I3 is equal to, writing here, I3 is equal to, this is V1 by 4, actually V1 minus 0 by 4, that is your V1 by 4, because this 4 ohm resistance is here, right. It is V1 minus V0, but V0 is 0. So, V1 minus 0 by 4. So, V1 by this thing 4, and then your I1. So, I1 I am writing here, that I1 is equal to, this is datum node, reference node 0. So, it is voltage here is V2. So, it will basically V2 minus 0 by 12. So, that means it is actually V2 by 12. This is your I1. So, I2 we have got, I3 we have got, and I1 also we have got, right. So, V2 by 12. So, all these things we will put in those KCL's equation, then we will get the equation in terms of V1 and V2. So, hope this is understandable. So, cleaning it, right. So, that we have written I2 plus I3 we are writing here, right. So, this is your I2 and this is your I3, whatever we have explained. So, after simplification we will get this equation 3 V1 minus V2 is equal to 20. Similarly, other thing also, this equation also we wrote at the time of explanation, and I2 is equal to then V1 minus V2 upon 8, and I1 is equal to V2 by 12. This also we have written, right. So, let me clean it. right. So, then upon simplification we got that your minus 3 V 1 plus 5 V 2 is equal to 60. Now, solve you solve equation 1 and equation 2, these two equations you solve, you will get V 1 is equal to 13.33 volt and V 2 is equal to 20 volt, right. So, this is the answer, but let me clean it. One few things I can tell, that you please solve it of your own. Here problem it is not mentioned, that you find out how much power is supplied by this current source and this current source. This is an exercise for you, whether how much power they are supplied, right. It may accordingly you will find out. It may be that is your two current sources are there, how much power by this one, this current source, and how much by this current source. This is an exercise for you. Thank you very much. We will be back again.